So this lesson covers area on a coordinate plane. And there's basically 3 different skills that we're going to go over to give you some practice and some instruction on using a coordinate plane to find area of different polygons. So the first thing you have to do is we're going to find an area of polygons on a coordinate plane, meaning they're going to draw a polygon for you, whether it be a triangle, a pentagon, a parallelogram, and you have to find the area. The second thing is to find missing vertices. Vertices are just the corners or the points on the ends of the polygons. So to find the missing vertices of triangles, rectangles, and parallelograms, meaning they'll give you some and the area, and you have to work backwards. And the third thing that this lesson covers is finding the area of other polygons on coordinate grid using a subtraction method. So the first thing we're going to do is we're going to go look at some review questions that we covered way back in September on the different how to plot points and reflecting points. So if I plot -3, 4, remember you go over before you go up. And then the second part says to reflect -3, 4 over the y-axis. So we know the y-axis is right here, and if I reflect it, it's going to land right here, and that point is 3, 4. Now you may remember the shortcut, which is if you reflect over the y-axis, the y-coordinate stays the same. Now I want to find the distance. When I'm finding the distance to the new point, I'm just going to count. I'm going to go 1, 2, 3, 4, 5, 6. I like to make little bunny hops because I think that makes sure that my counting is quite accurate. So I found the distance was 6 units. Now, here's comes in to one of our goals that we're hitting today is finding a missing vertex. So now the question says, if the triangle has an area of 12 square units, what is the third vertex or the third point of a triangle? Well, there's more than one answer. But what I do know is if the area equals 1/2 times base times height for the triangle, and I want the area to be 12, 1/2 times, my base is 6. I'm looking for the height. Oh, look at that. The height needs to be 4 units. Now, I took this 6 and I made that the base of my triangle. Remember, the base doesn't have to be on the bottom. So I have that as my base, and I'm going to go down 4 units. 1, 2, 3, 4. If I form a triangle with those 3 points, the area of that triangle is 12 units. That third point is at -3, 0. Now what's really cool about triangles is there was actually more than one right answer. So let me back up and let's see if I can find a different point. If I plot 0, 0 at the origin, this triangle still has a base of 6 and now has a height of 4, which would completely work for our formula. Actually, anything along the x-axis would work. So if I had 6, 0, that would work. If I had -5, 0, that would work. 1, 0 would also work. Anything along that x-axis where the height of my triangle would be 4, 1, 2, 3, 4, would completely give me an area of 12 square units. So if I look back here, what we've done is we've definitely found a missing vertex of a triangle. Finding the area of polygons on the coordinate plane, well, we had to find the area of that triangle once we made it. So I think we're pretty good on that one as well. Let's do a couple more practice questions before we get to that challenge number 3 goal. Plot the given vertices. So I'm at -2, 3. I'm at 4, 3. I'm at -2, +1. I need to make the 4th vertex of a rectangle. Well, that's going to be right there, which is 4, 1. Then I need to find the area. Well, to find the area of my triangle, I need to find the dimensions. So I have the length 1, 2, 3, 4, 5, 6, and 1, 2. I like to label them because then I think it really helps make sure that you're doing the right counting and then you have all the right steps. So I'm going to start by writing the formula, length times width. My length is 6, my width is 2. People have asked me this a lot, which one's which? It doesn't matter, 2 times 6 is the same thing. And I have 12 square units. Okay, let's jump ahead. I'm going to jump ahead to this parallelogram. Now on this parallelogram, I have 1, 3. I have 5, 3. I have 3, 1. And I need to make a parallelogram. Well, I know a parallelogram is 1, 2, 3, 4 is going to be the base. I'm going to make this the base, 1, 2, 3, 4. And my point is going to be at -1, 1. The bases of parallelograms are the same. I could have gone 4 in the other direction, and that would have gotten a 7, 1 as well. That would have also made this parallelogram. When I have the parallelogram, I have 4 times 2. The area is 8 square units. Okay, I got to get to that third goal. Our third goal is if I had a shape like this, how can I find the area? Now, whenever we have some irregular polygons on our coordinate plane, meaning like they're not the triangles or trapezoids or parallelograms we know those formulas for, we have to use a different strategy. This different strategy, I call it the subtraction method. I just made a big rectangle. Now the area of my big rectangle is the length times width. 1, 2, 3, 4, 5, 6. 6, 1, 2, 3, 4, 5, 6, 7. 7. So I know the area of my big rectangle is 42 square units. Now, if I just want to know the area of that inside pentagon, what I need to do is I need to subtract these triangles along the outside. So the first one I have, and I like to label them with Roman numerals because that way I keep my work organized. I have Roman numeral 1. That's a triangle, so its area equals 1/2 times base times height. 1, 2, 3. I know the height is going to be 3. 1, 2, 3, 4. The base is 4, and I have 1/2 of that. So I know that the area of that shape is 6 square units. Now, I'm going to find the area of the next triangle down here. We'll call that area 2. So for area 2, again, it's a triangle. 1/2 times base times height. Again, I have 1, 2, 3 is the height. I have 1 for the base, and then I have to multiply that by 1/2. So I get 1.5 for the area of that triangle. I have to do the same steps with these other 2 triangles. Again, all I'm doing is I'm going to find the area of these 3 sections, and then I'm going to subtract it from the big rectangle. So I have 1/2, I have a height of 2, 1, 2, 3. Notice how I count every time, trying to avoid any mistakes. I have this 4th one, which you do not have to shade it in. I'm just having fun with the colors on the Promethean board at the moment. The area equals 1/2 times base times height. I have a base of 2. And I have a height of 1, 2, 3, 4. I do like for you to get in the habit of showing this work. I think that's just a really good habit to get into. So now that I have all of these areas of my triangles, I need to add up the areas of the 4 triangles. I have 6 plus 1.5 plus 3 plus 4. You can use a calculator, that is fine. I have 10, 13, 14.5. So the area of my triangles was 14.5. The area of my initial big rectangle was 42. All I need to do is subtract it. 42 minus 14.5 gives you 27.5 square units.